All right, in this video, I'm going to talk about how to find the domain of a function analytically. So I'm only worrying about domain in this case. So let's look at the graphs here. I've got a rational function and I've got a square root function. These are the two common things that we have to look for when we're talking about domain. We'll also talk later on about logarithmic functions and how logarithmic functions will also have characteristics we have to consider. But let's talk about the rational and the square root function. Rational functions, you may remember from Algebra 2, anytime that your denominator is equal to 0, we do not define a fraction. So any number divided by 0 is undefined. Now, when I factor the top and the bottom here, if I factor the top here, let's see, I would do x plus 6, x minus 1, I think. I think that's how that will factor. Nope, that definitely doesn't. Wow, x plus 3, x minus 2 is what I want. Sorry, I'm having a little brain fart. X plus 3, x minus 2. Denominator here would factor is x plus 2, x minus 2. You may remember that in Algebra 2, you could cancel out the x minus 2's, and that creates what's called a hole in the graph, okay? And then the remaining x plus 2 means that there's a vertical asymptote at negative 2. So when I think about the domain for this, the domain, and the graph here will kind of illustrate this, we can have any values that go to the left. We will not have anything happen at negative 2. From there, we're allowed to have values until we reach that hole at 2. And then after that, we have graph defined. So when I think about the domain of this function, I have 3 sections here that I would illustrate with the domain. Okay? The square root function, when we think about a square root function, if I look at this, we know that square root values need to be positive. So if I were to plug in any x value in this function that is greater than 5, so let's say I plug in 6. If I do the square root of 5 minus 6, I get the square root of negative 1. We know that's imaginary. You'll learn that in Algebra 2. Since that's imaginary, we cannot define a function with an imaginary value. So we're not going to consider x values that make the square root a negative quantity. The domain for this, well, turns out any value that's less than or equal to 5 would allow for us to have a function here that is defined. So from negative infinity up till 5, we're allowed to have values of x that allow this square root to be positive. Okay, so we'll be talking about these in more detail. I'm going to actually skip over this part because I kind of already said the piece that I needed to say. So let's just go to rational functions. So the thing we need to remember about rational functions is you want no denominators to be 0. So what we do is we set the denominator equal to 0 and exclude those values. Okay, rational functions are going to have every number except for the things that make the denominator 0. Okay, so if we look back at our graph of a rational function, our domain here would have included any values of x except for negative 2 and positive 2, because in that case, that's what made the denominator of this function 0. Okay, so if I look at the first example here, this is already nice and factored, so we know x cannot equal 3 and x cannot equal 1. When I write my domain, I would go negative infinity to 1. And then from 1 to 3, I would have a domain. And then from 3 to infinity, I would not. That equates to a number line that looks like this. Okay. So the domain is going to be written with these three intervals. Okay. For the second function, we need to factor x squared minus 9 as x plus 3, x minus 3. So that means x cannot equal negative 3, and x cannot equal 3. So when I think of my number line for this, at negative 3 and at 3, I will have open circles because we're not defined in those places. So when I write my intervals, I have negative infinity to negative 3. Then I have negative 3 to 3. And then I have 3 to infinity. Okay? All right, looking at the third one, I'm going to have to factor this denominator. So I need two numbers that multiply to negative 6, while at the same time adding to negative 5. So that's going to be negative 6 and positive 1. So we write this as 2x squared minus 6x plus x minus 3. Factor by grouping. Factor out the 2x in the first group and a 1 in the second group. And that gives me the factors 2x minus 1 and x minus 3. So I'm going to go ahead and rewrite my denominator with that. Hold on, something doesn't seem right. Negative 6, positive 1. Hold on. 2x squared minus 5x. Oh, wait a minute. I think I might have factored wrong. Let me fix this. So I'm going to pause here and fix it. Sorry, I realized this should have been a plus 1 right here. Sorry about that. Okay. All right, now we're back in business. So I'm going to erase this because hopefully you know how to factor. I mean, you factored a lot in Algebra 2. And even if it's been a minute since you're in Algebra 2, hopefully this process comes back to you quickly. All right, so when I solve this for x, x will not equal negative a half. And on this one, x will not equal 3. So some of you might be number line people. That might help you visualize where you cannot have values. So when I write my domain, it's going to go negative infinity to negative a half. And then negative a half to 3. And then 3 to infinity. Okay? And that's how we're going to find our domain for any rational function. Now, square root functions, remember we want the quantity, so we want the square root part to be positive, so we set what's under the square root greater than or equal to 0 and solve. Okay? That'll allow us to exclude the values of x that are going to make the square root negative. So when I look at the square root of x plus 3, I need to see what makes x plus 3 greater than or equal to 0. So solving that out, I get x is greater than or equal to negative 3. When you think of what that looks like on the number line, if you have your number line, you would be graphing negative 3 with a closed-in circle and shading to the right. So the domain would be negative 3 to infinity. Notice this time we have the bracket because we can include negative 3. Next one, we're going to take 4 minus 2x, and we're going to set that greater than or equal to 0. Solving this out, I would subtract 4 on both sides. Now be careful, when you divide both sides of an inequality by a negative, your inequality symbol reverses direction. So x is less than or equal to 2, closed in circle, but this time we're shading to the left. Maybe if my pen will shade. There we go. So to write that, you would write negative infinity to 2. That's your domain. This example here, I would do 3x plus 1 greater than or equal to 0. Subtract 1 from both sides, and then divide by 3. So x would be greater than or equal to negative 1/3. Close circle, shade to the right. So we would write our domain is negative 1/3, comma, infinity. That's how you find the domain of square root functions. So now, what if I have both of those types of functions together? Okay. Well, first find your, let's see, we're going to find our excluded values of the fraction. And then we're going to find our, well, I won't call it excluded values, but we'll find our domain of the square root function. And once we find those, then we'll put it all together in a number line. So if I'm looking at number 1 here, I know that x minus 3 must be greater than or equal to 0, which means x is greater than or equal to 3. If I factor this denominator, what multiplies to negative 8 and adds to 2, that's going to be negative 2 and positive 4. So this will factor as x minus 2, x plus 4. So we would have to exclude, so x cannot equal 2 and x cannot equal negative 4. So what we're going to do is just make a number line of this information. Let's see, let's put 0 in the center. I know I've got 2 here with an open circle, negative 4 with an open circle, but I also know that x has to be greater than or equal to 3. And this one is going to take more precedence than the denominators here. So if I know from the square root part I cannot have anything less than 3, then it doesn't even matter about these excluded values. So when I write my domain, I would just write 3 to infinity on this one. If this had been an x plus 3 at the top instead of x minus 3, and therefore making x greater than or equal to negative 3, we would have had a hole in the middle of our shaded part, and we wouldn't have had an inequality quite like this. The next one, this one is a little bit different because the square root's in the bottom. So not only do we want that positive, so x plus 5 has to be positive, but in this case, because it's also a denominator, it cannot equal 0. So x has to just be greater than negative 5. So open circle, and then shade to the right. And that's how we would find the domain for this function. Okay. I want to illustrate one more example, but I don't have enough space to do that in here. So I'm going to clear this screen. So if you did not get all this down, pause so that you can see all this. Okay. All right. And now what I want to do is I want to make a slight change to this problem that we just did with number 1. I want to talk about that. So I'm going to change that numerator to a positive 3. Sorry, that's taking forever. I should have just waited. Anyway, so let's change this to x plus 3. And when I do that, that means x plus 3 must be greater than or equal to 0, which means x is greater than or equal to negative 3. The denominator still factors as x minus 2 and x plus 4. So we know x cannot equal 2 and x cannot equal negative 4. So if I still draw my number line, here's my negative 4 with an open circle. Here's my negative 3 that I would put a closed-in circle. Negative 2, negative 1, 0, 1, 2. Here's positive 2 where I'd have an open circle. When I'm looking at this, since x first off has to be greater than or equal to negative 3, I don't worry about this negative 4 over here. So I'm going to shade, but when I get to 2, that is an excluded value. I have to leave that unshaded. And if I wrote the domain for this, I would have the interval negative 3 to 2, and then I'd have 2 to infinity. So I wanted to show you what would happen in that situation. Okay, with that, go ahead and try some problems, and you should be in good shape.